Hello everyone, welcome back. This is Soumya Reddy S. from the Department of CSC, wearing the USN 1VE 21CS067, studying at Sri Venkateshwara College of Engineering. Today I am here to explain about the topic real-time operating systems. Real-time operating system. The real-time operating system is said to be a real-time if it is required to complete its work and deliver its services on time. The example of real-time operating system or flight control system. All tasks in the system must execute on time. The non-example is PC system. Hard and soft real-time systems. The hard real-time systems is failure to meet deadlines is fatal. The example flight control system. Soft real-time system. Late completion of jobs is undesirable but not fatal. Systems performance degrades as more and more job miss deadlines. The online databases. Qualitative definition. Hard and soft real-time operating systems. The hard real-time system is an validation by probably correctly procedures or extensive simulation that the system always meets the timings constraints. The soft real-time system is a demonstration of jobs meeting some statistical constraint suffices. The example is multimedia system, 25 frames per second on an average. Role of an operating system in real-time systems. Stand-alone applications. Often no operating systems involved. Microcontroller-based embedded systems. Some real-time applications are huge and complex. Multiple threads, complicated synchronization requirements, file system, network, windowing support. Operating system primitives reduce the software design time. Some of the features of RTOs are scheduling, resource allocation, interrupt handling, other issues like kernel size. Scheduling in RTOs or more information about the tasks are known as know of tasks, resource requirements, release time, execution time, deadlines. Being a more deterministic system, better scheduling algorithms can be devised. Some of the scheduling algorithms in RTOs are clock-driven scheduling, weighted round-robin scheduling, priority scheduling is also known as greedy or list or event-driven. Let's discuss the content of scheduling algorithms in RTOs. Clock-driven. All parameters about jobs, release time, execution time and deadline known in advance. Schedule can be computed offline or at some regular time instances. Minimal runtime overhead. Not suitable for many applications. Weighted round robin. In this, job scheduled in FIFO manner, time quantum given to jobs is proportional to its weight. Example use high speed switching network, QoS guarantee, not suitable for precedence constrained jobs. Job A can run only after job B. No point in giving time quantum to job B before job A. Priority scheduling. In this, processor never left idle when there are ready tasks. Processor allocated to processes according to priorities. The priorities are static at design time, dynamic at runtime. Now, priority earliest deadline first, known as EDF, process with earliest deadline given highest priority scheduling. Least slack time first. Slack equals to relative deadline minus execution left. Rate monotonic scheduling, RMS, for periodic task. Task priority inversely proportional to its period. Some of the resource allocation in RTOs or resource allocation. The issues with scheduling applicable here. Resources can be allocated in weighted round robin, priority based. Some resources are non-preemptible. Example semaphores. Priority inversion of priority scheduling is used. Priority inversion. Here the graph is shown about the priority inversion. Here the x-axis is priority and the y-axis is time axis, and it is divided into three tasks: task A, task B and task C. Task B is C request R and task A is request R. Let's discuss about the solutions to priority inversion. The solutions to priority inversion are non-blocking critical section. In that, higher priority thread may get blocked by unrelated low priority thread. Priority ceiling. In each resource has an assigned priority. Priority of thread is the highest of all priorities of the resources it's holding. And the priority inheritance. The thread holding a resource inherits the priority of change blocked on that resource. Other RTOs issues are interrupt latency should be very small. In that, kernel has to respond to real-time events. Interrupt should be disabled for minimum possible time. For embedded applications, kernel size should be small, should fit in ROM. Sophisticated features can be removed, no virtual memory and no protection. Other RTOs are Linux operating system. In that microkernel architecture, kernel provides scheduling or interrupt handling. The additional features through kernel plug-ins or KPIs. KPI is nothing but kernel provides interrupt. TCP or IP stack file system, kernel provides interrupt or multi-threaded. Memory protection or daemon paging optional. Development and deployment on the same host. Operating system support for compilers or debuggers. VX works in monolithic architecture, real-time POSIX compliant, cross-development system, object-oriented operating system. By this, I'll end my session. Thank you.